All right, welcome to day 3 of Unit 1. Here we're going to talk about inequalities and piecewise functions. So just remember that with inequalities, we're talking about less than and greater than. Less than is a symbol that's pointing to the left. I'm going to draw that a little bit better. So that's less than. It's not that the alligator eats the bigger number anymore. You're in high school. You're in PreCal seniors. And then the one that's pointing to the right is greater than. And if there's a little bar underneath it, it's or equal to. So let's just do a quick review of this. So if we're talking about a closed interval, we have two numbers that everything's in between them, including those two numbers. So what does a graph of a is less than or equal to x is less than or equal to b look like? Well, since we're including a, it's closed. Since we're including b, it's closed. And we're talking about everything in the middle. So that's what it looks like. A lot of teachers teach this differently. If you want to draw a line above it or if you want to highlight in between, it's up to you. An open interval is almost very similar, but it doesn't include A and B. So what we do is at A and B, we have open circles, but again, everything's in between. And then we can have half open or half closed, whichever way you see it. In this case, we're including A, but not including B. So there's a closed circle at A, but an open circle at B. We cannot include A, but include B. So that means open circle at A, closed at B, and everything in between. If we're talking about greater than or equal to A, that means that it's open or closed at A and everything to the right. So if you have your X on the left-hand side, it really helps with which way your graph goes. What if X is less than B? Well, that means we're not including B, so it's an open circle, and it's less than, so it's everything to the left. So let's do some more examples. So what if I give you that X is less than -5 or X is greater than or equal to -3? Well, I'm going to draw a number line. -5 is less than -3, so I'm going to make sure it's to the left of the number line of on the number line of -3. Less than -5 looks like this, and then greater than or equal to -3 looks like this. And that's it. Since it was asking for or, it's everything in both. So that's our graph. Interval notation needs to be written from left to right. If you notice that this graph goes all the way to the left, all the way to the left is -infinity, but stops at -5. Since -5 is not included, we're going to put a parenthesis, and then we're going to unite that with the other interval from -3, which is included, so we're going to put a square bracket all the way to the right to +infinity. It does matter which side infinity and -infinity goes, so make sure that -infinity is on the left and +infinity is on the right. What if we have an interval that's between -2 and 4, including -2 and 4? Well, I'm going to draw my number line. -2 is less than 4, so make sure it's to the left. There's square brackets, so they're both being closed, and then you do that. If you're talking about everything in between two numbers, what I usually like to do is draw the same thing every single time. So -2 is less than x is less than 4. However, it does change if the circles are closed or open. Since both of these are closed, they both have to be or equal to. So make sure that compound inequalities that look like this should go from left to right, least to greatest, and the inequality should always be less than. What about this next one? We have everything between -3 and 6, but not including -3 and including 6. So again, talking about all the numbers between -3 and 6. So same thing like I did for the last one. But I need to make sure that, since I'm including 6, I put or equal to. In my interval notation, we kind of write out almost like an ordered pair, but we're talking about all the numbers from -3 to 6, not including -3, but including 6. And in this last one, we have -infinity and -1 as our interval, including -1. And then we have 5 and 7. You don't have to draw your number lines to scale. So since we're including -1, it's a closed circle. Since it was going from -infinity to -1, it's all the things to the left of -1. 5 has a parenthesis, so it's not included, but 7 has a square bracket, so it's closed. So it's everything in between those. So how do I write an inequality for this? Well, everything to the left of -1, including -1, is less than or equal to -1. Or we're talking about everything between 5 and 7. So everything in between, again, same notation, but we're not including 5, but including 7, so we're equal to. So piecewise functions are very particular. So it all depends on what value of x, and the interval of x's that we're talking about is denoted here. So if x is less than 0, we're looking at this first equation. If we're talking about greater than or equal to 0, we're looking at the second equation. So what I would like to first do is label this 1 and 2, and just go through and make sure you know which equation we're going to use. Well, if we're talking about -3, it's less than 0, so that means we're going to use equation 1. And since d is right here, I'm just going to do part d. -1 is also less than 0, so I'm also going to plug that into the first equation. -1/8 is less than 0, so plug that into the first equation. 0. If you notice, 0 is included in both of those inequalities, but the second one is the only one that has or equal to 0. So I'm going to plug in 0 only into the second equation. 1 is greater than or equal to 0, so we're going to plug that into the second equation. And then 4 as well is greater than or equal to 0, so we're going to plug that into only the second one. So you cannot plug in these values of x's into both equations. It's either one or the other. And if there's multiple of them, again, you can only plug in those numbers into one of them. So what happens if you plug in -3 into 2x plus 1? Well, you get 2 times -3, which is -6, plus 1 is -5. If you plug in -1/8, so I'll show that work. So 2 times -1/8 plus 1. 2 times -1/8 is the same thing as -2/4 or -1/2. Oh, no, sorry, -1/4. -2/8 reduces to -1/4, and then plus 1, and then you get 3/4. If you plug in 1 only into the second one, because again, 1 is greater than or equal to 0, we get the square root of 1 is just 1. F at -1, again, is only going to be plugged into the first equation because -1 is strictly less than 0. So plug in -1 into 2x plus 1, get 2 times -1, -2, plus 1 is -1. If you plug in 0, again, 0 is included in the second equation, so square root of 0 is just 0. Plug in 4 into the second equation, the square root of 4 is just 2. Some of y'all might be asking, well, I thought the square root of 4 was plus or minus 2. Well, that's only if you're solving an equation that says x squared equals to 4. That's where you get plus or minus. If I'm just asking for the square root of 4, it's just 2. Now, what if I have these three equations? So again, just real quick, what I like to do in class is just ask y'all to first just tell me which equation does this go into. So if you're talking about plugging in -5, well, -5 is less than or equal to -1, so we're going to plug that into the first one. -2/3, which interval is that in between? Yes, it's between -1 and +2, so we're going to plug that into the second equation. What about +1? The second equation. What about -1? Well, -1 is included in the second equation, but it's just strictly less than. So the only one that's equal to -1 is the first one. So we're going to plug in -1 into the first equation. 1 2/3 is between -1 and 2, so we're going to plug that into the second. And pi, you should know this as a constant as 3.14159, or however many digits, at least 3.14. Pi is bigger than 2, so we're going to plug that into our third equation. So now we just need to do the arithmetic. What happens if I plug in -5 and for x into the first equation? Well, if you notice, there is no x. So that means our output is always 4. So honestly, anytime that I'm plugging into the first equation, my output's always going to be 1 or 4, no matter what I plug in, because there is nothing to plug in numbers into. What about -2/3? Well, I'm plugging in -2/3 into the second equation because it's between -1 and 2. So we have 3 times -2/3 plus or minus 1. 3 times -2/3 is -2, minus 1 is -3. 1 2/3, it's going to be helpful if you remember how to change mixed to improper. A student told me this is called the Texas method. because what you do is you multiply the denominator by the whole number and add it to the numerator. So you have an x and a t, so tx. So 3 times 1 is 3 plus 2 is 5. So 1 and 2/3 is the same thing as 5/3. So if we plug in 5/3 into this equation, you end up getting 3 times 5/3, which is 5, minus 1, which is 4. Just a lot easier to deal with improper fractions than mixed. G at 1, that was between -1 and 2, so we're plugging into the second one. 3 times 1 minus 1 is 2. And then part F here is plugging in pi into the third equation, and we're just going to leave it as pi squared plus 1. There's no need for us to know how to square pi off the top of our heads. Then on our last page here, we have graphing piecewise functions. So there are people that do this differently. Different teachers teach this differently. One thing that some teachers do is that they draw the whole graph and erase what they don't want. So what I'm going to do, just to show you real quick, if we're talking about -3 being your y value, that means your graph is always going to be -3. However, this graph only tells us that it's -3, or this piecewise function only tells us our output is -3 if y is less, or x is less than 0. That means that I cannot have any of this graph that's to the right of 0. So I would have an open circle here, and it would be that. That's what that piece would look like. What I like to do is I like to make tables of values. So have x and y. Since we're saying x is less than 0, I'm going to use 0 as my first x value and then just start plugging in numbers that are less than 0. However, we need to make sure that we understand that that's going to be an open circle because it's strictly less than 1. Well, again, just like what we did earlier, there are no values of, there's no x to plug in numbers into, so your output is just always -3. So I have an open circle at 0, -3, and then I just have a bunch of dots, but I only can plug in numbers. I mean, you can plug in fractions and decimals if you want to and plot those points, or just connect the dots. Now for the second equation, again, I'm going to have a table of values. I always just like plugging in numbers because it's easier to deal with. Since we're talking about greater than or equal to 0, I'm going to start off plugging in 0, and I need to make sure that this is going to be closed because it's or equal to. Then I'm going to plug in x values that come out as nice numbers if I square root them, like square root of 1. That's fine. Square root of 2 is a decimal, square root of 3 is a decimal, square root of 4 works. And you can keep kind of going and think about another number you can square root evenly, and 9 is one of them. So you end up getting 0, 1, 2, and 3. But I don't have room for all of those points, so I'm just going to have 0, 0, which again was a closed circle, 1, 1, and then 4, 2. Now, these are not the only points on the graph. What you need to show is every single value of x that's greater than or equal to 0, but you do that by just connecting your points and making sure your square root function looks like this. So these are piecewise functions. So you need to make sure to check, did you draw a function? So if you draw a bunch of vertical lines, do you hit the graph more than once? Well, some of y'all might be asking about here. Well, we do hit the graph here. Do we hit the graph here? No. Since this is an open circle, that it passes the vertical line test. So we're good. This is a function. All right. What about this next one? Well, again, what I'm going to do is I'm going to create a table of values for each of these equations because I don't know what these graphs look like. So the first equation tells us greater than or equal to 0. So I'm going to start off plugging in 0, and then I'm going to start plugging in numbers that are less than 0 that I can also square root. So that's going to be -1, -4, -9. So in this problem here, since we're or equal to 0 on the first equation, this is going to be not open, but closed. If you plug in 0 into this equation, -0, square root that is still 0, -3 plus 0 is -3. If you plug in -1, -1 is +1, which is we square root is 1, -3 plus 1 is -2. Plug in -4, -4 is +4, square root of 4 is 2, plus -3 is -1. And if you plug in -9 to do all the math, you end up getting 0. Then I'm going to do another table of values for the second equation. Again, I'm going to start off with the value of 0 that is in the inequality, but this one we need to make sure it's open because it's strictly greater than 0. And then we're absolute valuing, and there's not really any particular numbers that we can't absolute value evenly, so I'm just going to plug in 1, 2, and 3. So we plug in 0, -0 plus 2 is 2. Plug in 1, -1 plus 2 is 1. Plug in 2 is 0. And then plug in 3, you end up getting -1. And you can keep plugging in numbers if you want to, just to make sure that you're doing that correctly, but I'm just going to go ahead and plot those. So 0, -3 was a closed circle, -1, -2, -4, -1. And again, my table has more values, but I don't have enough room on my graph, so I just know it goes like that. Then 0, 2, we said was an open circle, and then 1, 1, 2, 0, and 3, -1. Again, what you could do is use your function transformations that you learned in Algebra 2 and Algebra 1 and erase the piece of the graph that you don't want. All right, lastly, we have this one here. So our first table of x's and y's, again, I'm going to use 1 because it's x is less than 1, but I'm going to make sure that I put a note here that that's going to be open because it's less than 1. And I'm going to plug in values of x's that are less than 1. So 0, -1, -2. If you plug those numbers into 3 minus x, 3 minus 1 is 2, 3 minus 0 is 3, 3 minus -1 is 4, 3 minus -2 is 5. So we end up having a point at 1, 2, which is going to be an open circle, then 0, 3, -1, 4, and -2, 5. Again, if you know that that's a line and you can draw the line, just erase everything that's to the right of 1. Then make an x and y table for the second equation. So again, I'm going to make sure I use the number 1 because it's part of my inequality. At this time, it's going to be closed. And I'm going to plug in numbers that are bigger than 1. And you can plug in any numbers that are bigger than 1. I just like plugging in integers, so like 2, 3, and 4. If you plug in 1 into -x squared plus 3, you get 2. Plug in 2, you get -1. Plug in 3, you get -6. Plug in 4, you get -13. But wait a minute, if I go and plug in a point 1, comma 2 and make it closed, well, it's the same point that was earlier, so it's closed. Now it's closed. It's not both open or closed. It's not like a door, it's one or the other. But if you're going to close it, it's now closed. Then 2, -1, and then 3, -6. And this is supposed to be a part of a parabola, so it looks something like that. I'm going to maybe fix that a little bit. There it goes. That's like a little bit better. All right, so that's our piecewise function for that. So understand that when you plug in things into a calculator or Desmos or anything like that, what it's doing very quickly is making tables and connecting points. It just does it in lightning speed. You, on the other hand, may be a little slower than a computer, so you just need to process through it, make tables, plug in numbers, and see what happens to the graph. Make sure you practice this stuff in your homework, and